Suppose we are given the following numerical data right here. Which single graph can show the data spread, center, outliers, and symmetry all at once? Is it A, box plot? Is it B, scatter plot? Or is it C, histogram? This session is about answering these types of questions. By the way, the answer is box plot. And the answer was over there on the top two. So if you were not able to figure out the answer, this class is definitely for you. So box plot, another name for that is a box and whisker plot. It's a graphical representation of data distribution based on 5 key summary statistics. These are your 5 key summary statistics. So the first one is minimum whisker. It is the smallest non-outlier value, which would be this point right here, this one. Okay, then you have Q1. Another name for that is first quartile. 25% of your data is going to be lying below this. That would be this value right here. Okay, this point. So this is your Q1. Then you have Q2. Another name for that is median. This is the middle value where 50% of your data lies below this. That would be this point right here, which would be indicated by this line right here. Okay. Then you have Q3, which is a third quartile. 75% of your data is going to be lying below this. That would be this point right here. Okay, this is your Q3. Then you have maximum whisker. This is the largest non-outlier value. This would be this right here. Okay, the box plot shows the following. Interquartile range. That would be this right here. You can calculate your IQR using this formula, Q3 minus Q1. It is the range of values from here to here. So if your Q1, let's say, is 5 and your Q3, let's say, is 9, so your IQR is going to be equal to Q3 minus Q1, which would be 9 minus 4, and the answer comes out to be 4. In other words, 50% of your data, okay, is going to be lying in this range right here. This is where 50% of your data lies. That's what it means. Okay, then there is a line inside that is a median, which would be this line right here. Let me remove this. That would be this line right here. Okay, this is your median. Okay, then you have whiskers, which would be this right here. These are called whiskers, and they extend to minimum and maximum values. So minimum to maximum values. Then you have dots or stars. They indicate your outliers, which would be this point right here. Okay, these are called your outlier points. Let's say we have temperature readings given by this numerical data. And I want to see my 5 key summaries, minimum, Q1, Q2, Q3, and maximum. Assuming you have calculated these values, by the way, if you do not know how to calculate them, you can actually watch my video on how I calculate these values. Assuming you have calculated them, we can plot these points. So this would be my minimum right here. This would be -2. So this right here is my -2. Then I have Q1, which is plus 4.25. That would be this value right here, 4.25. Then I have Q2, which is my median. That would be 9. So if you come down, this would be right here, 9. All right. Then I have Q3, which is 14.5. That would be right here, 14.25. So I know my Q1, Q2, Q3. I plotted them. And then plot your maximum whisker, plus 20. That would be this right here. All right. So this, if you drop it down, this value would be somewhere, would be over here. This would be plus 20. So any values that are on this side and any value on this side, those are your outliers. So my minimum is -2 and the maximum is 20. So any value on this range and these values, these are my outliers. So you can identify your outliers as to be -20, 40, and 45, which would be this one and these two values. Okay, how about your IQR? Well, your IQR is Q3 minus Q1. I know my Q3, I know my Q1, and my Q3 minus Q1 will be come out to be 10.25. In other words, this right here is 10.25. 10.25. And what this means is that the middle 50% of my data lies within the range of 10.25. That's what your IQR means over here. So box plots, they are robust to noise. Let's understand this through an example. Let's say we receive some noise to our temperature reading. This is my temperature reading and this is my noise right here. Let's plot box plot for both the data without and with the noise. So I do my box plot for without noise and then I do it with noise. And as you can see, your shape of your box plot is almost identical. Look at that. It's almost same. You can also see that your median, this which is the center line, it barely changes. So this is my median right here. Okay, look at this median and look at this median right here. Okay, they barely change. They are almost identical. Okay, your IQR stays almost the same. Your IQR is this distance right here. Look at this distance and look at this distance, almost identical. Now in this case, my outliers are these points. Okay, so this should convince you that the box plot, they are robust to extreme values. Now box plots, they are used to compare distribution of data among groups. So I have plotted box plot of iris dataset, and there are three different categories over here. There's a Setosa, versicolor, and virginica. Okay, so let's look at the Setosa first. You can see that it has the smallest sepal length overall, and you can see that from here to here. Okay, it extends from here to here, which is 4.1 maybe to 5.6, something like that. The median is around 5 centimeter. You can see that this is your median right here, almost 5 centimeter. The spread of your IQR is tight. In other words, your values are consistent. This right here is your IQR, and your IQR is smaller over here. Okay, these are small value compared with this one and this one. So in this case, that tells me that here my values are more consistent. Okay, now let's look at versicolor. This one, it has intermediate sepal length. So this right here, okay, the sepal length is in this range over here. Okay, the median is around 5.9 to 6 centimeter. This right here is approximately 5.9 to 6 centimeter, and it has a slightly wider IQR. In other words, there's a moderate variation in your data. So the data is which extends from here to here, okay, like in this range. Okay, this is your IQR where 50% of your data lies in this range. So you can see this one has a little bit higher, a little bit larger IQR, and there are no outliers. As you can see, no outliers, no outliers. Same thing over here, no outliers, no outliers. Now let's look at virginica. It has the largest sepal length, and median is around 6.5 to 6.6 centimeter. This is your median right here. Okay, almost 6.5 or 6.6, yeah. And it has the largest sepal length. You can see your sepal length goes from here to up to here. It is more spread, indicating more variation within the species. You can see that this distance, okay, from here to here is higher, and you can even see the IQR. Your IQ is a little bit more over here compared with the rest of them. Actually, yeah, this one actually has a little bit more with the at least with this one. And then whiskers, they extend higher. In other words, that indicates the presence of some longer sepals. So you can see your whisker over here and you see your whisker. It is actually this particular whisker is extending a little higher. So that tells me that there are some really long sepal length. And it has one outlier. You can see that from here. This is your outlier right here. So box plot, it allows you to see the skewness of your data. So let's take a look at example of normally distributed. Here, your median would be at the center of the box and your whiskers are almost same on both ends. So as you can see, I'm actually plotting a histogram over here. This is a corresponding box plot. You can see that my median is right there, almost at the center of my box. Okay, this is my box right here and this is almost at the center. And also, your whiskers are almost same on both ends. You can see the distance from this side and the distance on this side. They're almost identical. Then you have positive skew. Another word for that is a right skew. Here, your median Q2 will lie closer to your first quartile. So your Q2 is going to lie closer to Q1. That's what it's saying. And the whisker at the lower end is shorter. So this whisker right here is going to be shorter than this whisker. So this is a shorter whisker. Then you have negative skew, a left skew. Here, my median Q2 lies closer to the third quartile. So this is my Q2 and this is my Q3. So here my Q2 is closer to Q3. And the whisker at the upper end is shorter. In this case, this right here, this whisker, the length of this is smaller than the length of this right here. So histograms, they are great with large data sets for summarization. Now, histograms need many bins to make sense and they can look cluttered with 50,000 points. These are my 50,000 points and I made a histogram over here. And you can see it's kind of become a little clustered, okay? And box plot, on the other hand, it summarizes your entire data set in a clean, compact view where you can see your median, your IQR, and your outliers. You can identify your outliers right here. Okay, you can identify your median, which is right here, this one. You can even identify your whiskers right here. You can identify your IQR, which is right here. So a box plot still looks clean while the histogram may need many bins and can sometimes look messy. So, what makes box plot special? Number one, outlier detection. They can instantly flag your unusual data points that could indicate errors or interesting phenomena. We saw that. They are robust to noise. They use medians and quartiles, so it's less affected by extreme values. Group comparison. We saw that using our iris dataset. You can compare distribution between multiple categories. Skewness. We were able to identify left skew, right skew, or maybe zero skew, which is your normal distribution. And they're great for larger data sets for summary. We also saw that histograms need many bins. On the other hand, box plot, they can scale very beautifully even with a huge data set. It summarizes thousands of data points in one small plot.